With your query window up, let's create a new table. And let's call this Human Resources dot Room Chart. And what this is this will keep track of all of our guest meeting rooms and their sizes and everything. But we're going to start off with a very simple design. We're going to say r_id for room ID, which we'll set as an int, and we'll say that is not null. Let's do another field, and let's call this one the room code, which we'll set as a char 3, and that can be null, at least in the short term. Create this table. Now, notice it has 2 fields, but currently has no records in it. Okay, if I were to insert one record, how much room would it take up? Let's insert one record right now. Insert into Human Resources.RoomChart the following values. Room number 1 will be the RLT room, and since that's chars, let me put single quotes around it. Run this insert statement, and let's check our record. There we go. Okay, how much room does an int take up, and how much room does a char 3 take up? Well, let's go ahead and look at the design of the table. Let's expand this, and let's go to the Human Resources Room Chart table. And let's right-click it and get its design. If you were on SQL 2005, you would choose Modify. Okay, our first field is an integer data type, which is taking up exactly 4 bytes. Our second field is a char 3, which is taking up exactly 3 bytes. Therefore, this record is taking up 7 bytes. If we were to insert another record for room 2, it would take up an additional 7 bytes. Let's say room 2 is QXT. Let's run this insert statement, and then we'll select and look at our records. We know the data payload for row 1 is 7 bytes, and we know the data payload for row 2 is 7 bytes. Therefore, this table is taking up 14 bytes of data. So what are all the calculations that go into row sizes and data types to be able to calculate the expected consumption based on your incoming data? That's what this lab is all about. So we've left off with a table design that takes up 4 bytes for the first field and 3 bytes for the second field, giving us a total data payload of 7 bytes per record. And then we put 2 records in it, and so we're consuming a data payload of 14 bytes. Well, what if we added 2 more records with a slight variation? Now, we're going to use a row constructor here so we can do it in one statement. We're going to insert row 3, which is the TQW code, and row 4, which is XW. That's only 2 letters long. Let's execute this, and let's look at this data. Now, this first row takes up 4 bytes, and then 3. The second row, 4 bytes plus 3. This next row, 4 plus 3. Now, this takes up 4 bytes, and this also takes up 3, even though there's 2 characters in it, because a char 3 takes up 3 bytes whether you use it or not. It's not designed for a variable length of characters. So if you do not use it, the space still gets used. So what is our total calculation? Well, if it's taking up 7 bytes of data per row, and we have 4 rows, that's 28 bytes. Except that's just calculating the data portion. This row has a header, which you can kind of see here as its representation. That header contains 2 bytes to say what kind of record it is. It also contains an offset for the null block, which we'll learn later. That header is taking up 4 bytes. So this first row is taking up a 4-byte header and 7 bytes of data. So the first row is taking up 11 bytes. The second row is taking up 11 bytes. These 4 rows, each taking up 11 bytes, with the calculation given so far, is taking up a total of 44 bytes. Calculating the data row usage of fixed-length data is pretty straightforward. We also have the ability to add variable-length data. Let's go back to the design of our table, and we're going to add a new field. We're going to have a room name, r_name. And we're going to say some rooms are really long in their names and some rooms are shorter in their names, just like you've known people with long last names and short names. So we're going to say that room names can go up to 25 letters in length. So I'll say n var char, and in the parentheses, put 25. And this can be null. Let's save this table, rerun the query, and notice currently for these 4 records, we don't have any room names. Well, let's go ahead and start adding some names by saying edit top rows. And the name of the first room, the RLT room, that's short for the Renault Langford Tribute Room. So let me type that, Renault Langford Tribute. That's taking exactly 25 characters of the 25 possible. So that one maxed out the capabilities of the field. Second one, the QXT room, is the Quinault Experience room. That will be 19 characters long. The next one, TQW, is Tranquil West. That will be 12 characters long. It has no hyphen in it. And the fourth room is XW, or Xavier West. That's 10 characters long. Okay, let's close out of here. And let's look at our data. Let's delve into the data types and their consumption patterns before asking you how much each of the rows of the last example is actually consuming. Now, let's start off with the fixed-length data types, like an integer. Regardless of what you put inside that field for any given row of an integer, it's always going to take up 4 bytes. A char3 is another fixed-length data field. A char3 will always take up 3 bytes. How about a char4? Well, since it's 1 byte per character and you got 4 characters, that's going to take 4 bytes. Now, there's a more advanced character set that will support not only the types of characters you see on your keyboard, but also international characters like German umlauts, kanji characters, Chinese writing, all kinds of stuff that is considered international. That is known as Unicode. N is the symbol for Unicode in a SQL data type. So if you see an N char, that means you're going to take up 2 bytes for every Unicode character. So if you have an N char of 3, that consumes 6 bytes. Therefore, a fixed-length N char 4, since it's 2 bytes per character, that's going to take 8 bytes. Now, let's go back to the regular character types that take up 1 byte per character. And let's give it a varying length, like a var char 10. Perhaps some words are going to be 10 letters long and some are going to be 2 letters long. How much does a var char 10 consume? Well, it takes up 2 bytes to have a variable length, and then it takes 1 byte per character. So a var char 10 could take up to 12 bytes. Now, if you only put 2 characters into it, it would take up 4 bytes. So basically, a varchar consumes 2 bytes plus 1 byte per character up to the maximum that you can fill. Therefore, a varchar 15 could take up to 17 bytes. If we take a varchar 8 and only partially fill it with 2 letters like the word yo, it takes up 4 bytes of space. Why? Well, yo is actually only 2 bytes worth of data payload, but with variable length data, we have to dedicate 2 bytes for every row for every variable length data type in what's known as a variable block. A variable block is necessary because it's impossible to predict the beginning and the ending, similar to what you see with the 2 single quotes here. Isn't that taking up 2 bytes just to mark the beginning and the ending and to make it really clear? Quotes don't really take up any space. It's the beginning and ending marker inside of SQL that takes up the space. Yo would take up 2 bytes of data, and 2 bytes would be dedicated to the variable block. So young, Y-O-U-N-G, is 5 bytes of variable length data, and again, just 2 bytes dedicated to the variable block. The word youngest is taking up the full 8 bytes of variable length character in this varchar 8, and it's taking up 2 bytes dedicated to the variable block. Now, a common question I get is, What if I declare a varchar 10 and I put 2 letters in there like RL, and I declare a varchar 15 and I put in 2 letters RL? Is there a difference? No. In both situations, those would consume exactly 4 bytes. Okay, if it costs 2 bytes just to own a variable length character, how about a variable length of Unicode characters? Now, how about an nvarchar 10? We know that could take up to 20 bytes of Unicode characters, since 2 bytes are dedicated to the variable block, and an nvarchar 10 can take up to 20 bytes of payload data. The total consumption possibility for an nvarchar 10 is 22 bytes. If you put 6 characters in an nvarchar 10, like the word sunset, it would take up 12 bytes for the characters and another 2 bytes for the variable length block, so that would consume a total of 14 bytes. Let's go back to our room chart table and look at the design and the population and estimate the consumption. Now, of our 3 fields, the first 2 are an int and a char3, which are fixed length data fields. And the last field is a variable length field. It's an nvarchar 25. Well, we know exactly what the first 2 fields are going to consume before we even look at the data. The third field, we're going to have to look at the data to know what it consumes. Let's take a look at the first row. Okay, we know for sure that the header and every row takes up 4 bytes. So we're using 4 bytes for the header of this row. Our fixed length data consists of the row ID and the row code. 4 bytes for the ID because it's an integer, 3 bytes for the code because it's a char3, so our fixed length data is consuming 7 bytes. How about our variable block? All we have to do is count the number of fields that contain a variable length data type. Currently, there's only 1, so we only have 2 bytes for our variable block. Well, our variable block is going to consume 2 bytes. We also have exactly 25 letters in lengths for tribute, so that's Unicode characters. Those 25 characters are going to take up 50 bytes. So we're going to add 4 bytes to 7 to 2 to 50. Two important rules about the variable block we need to know before we do any more data row calculations, and that is number 1, the creation of a variable block takes 2 bytes. Number 2, it's going to take up 2 additional bytes for each variable length data type in your table design. Let's use an example. This is the design view of the employee table. You know for sure there is a variable block because you have 1 or more variable data types, namely last name and first name. They are both variable data types. So, a variable block with 2 bytes was created. 2 more bytes were added to the variable block because of last name, and 2 more bytes were added because of first name. Therefore, the employee table is taking up 6 bytes in a variable block for every record added to this table. Let's take a peek at the customer table's design. 5 fields total. Looks like 4 of the fields are variable length data types. So, we've got to set up a variable block. That costs you 2 bytes. Then, we have to spend 2 more bytes on every single piece of variable length data. We've got 4 of those fields. That's 8 more bytes. Therefore, on each record of the customer table, the variable block will take up a total of 10 bytes. Let's repeat this process for row 2. Row 2's header takes up 4 bytes. The fixed length data consists of an int taking up 4 and a char taking up 3. So the fixed data takes up 7 bytes. The variable block is taking up the number of fields that have variable length data, and there's only 1 of them, and multiplying that by 2. Finally, the Quinault experience, these are Unicode characters, so that's taking up 38 bytes. With your header taking up 4 bytes, your fixed data payload taking up 7 bytes, your variable block taking up 4 bytes, and the amount of variable data in your second row taking up 38 bytes, total memory space used for row 2 is 53 bytes. Lab 3.1, Skill Check 1. Calculate the space consumption of rows 3 and 4 according to the table design you see here.